Hi, I'm Bob Lazar. During late 1988 and early '89, I worked on the propulsion systems of extraterrestrial vehicles for the United States government. The hardware and technology I was exposed to should be placed in the proper hands of the scientific community, and it is the right of every person on Earth to know that there is physical evidence which proves that there is life elsewhere and that at least one form of that life has been here. For those of you whose information about me is limited to this video, I'll give you a brief background. I'm a physicist. I have degrees in physics and electronics technology. I've worked in a number of scientific programs, some of which require top secret and above top secret security clearances, of which the most easily verifiable is my early 1980s job here at the Los Alamos Mason Physics Facility in Los Alamos, New Mexico. Between December of '88 and April of '89, I worked as a senior staff physicist in what has to be the most secret project in history. My place of work was a facility at an area known as S4 on the Nellis Air Force Range in central Nevada. Area S4 is located approximately 15 miles south of the infamous Area 51 installation at Groom Lake, where the U-2 and SR-71 spy planes were developed. For the duration of my employment at S4, I was paid by the United States Navy. For the purpose of this video, I'm going to segregate the information contained here into two separate parts. The first part will deal with information with which I've had hands-on experience and personal instruction. In other words, not only did I read briefings and not only was I taught the theories of these technologies, but they were demonstrated for me and I know they are true and accurate. Some of the points covered in this first section will be how vast distances of space are traveled by virtue of an intense gravitational field, how this gravitational field is generated, what the power source is and how it functions, and general information about disks and the project at S4. The second part of this will deal with subjects on which I've read supporting information, yet for the most part I had no other way to corroborate the information or ascertain its accuracy. When we get to part two, it'll be obvious why proof of some of this information could not be conclusive. Some of the points covered in this second section will be information about the beings that brought us this technology, and how these beings have historically interacted with man. I've been prudent in selecting what to expose here, and I think that some of this information should not be made available to the general public. This information is being conveyed to you as it was to me, with the exception that in most cases I've simplified things for those of you with non-scientific and non-technological backgrounds. So let's begin. At the beginning of this first section, I'm going to give you 3 short science lessons, and once you've learned them, you'll not only know more about interstellar travel than almost anyone else in the world, but you'll know the actual method another civilization has used to travel from another star system to the planet Earth. Now, during the course of this, I'm going to have to relate information that I've learned at S4 to information that we're already aware of. And when I say we, I mean the general mainstream scientific community. So as not to waste too much time explaining established scientific facts and theories, when I say we know this or we know that, please feel free to consult any qualified scientist, professor, or science teacher to have them explain my statements to you. One of the most predominantly asked questions is, how is it possible to cross vast expanses of space without exceeding the speed of light? Or how can you travel in reasonable time and economy between points that are light years apart? Now keep in mind that the speed of light is 186,000 miles a second, which translates into roughly 669 million miles an hour. And a light year is a distance traveled in 1 year at the speed of light. Proxima Centauri, which is the star system nearest ours, would take 4 years to reach traveling at the speed of light. So up until now, when we've examined the requirements to travel these distances, we've always had to consider the problems of traveling at a speed near the speed of light. This poses problems with propulsion, navigation, fuel capacities, and even when you consider the effects of acceleration on space-time, which include time dilation, mass increase, length contraction, and a whole host of other things, it quickly becomes evident that this type of travel would require a level of technology that man has not yet achieved. The truth of the matter is that traveling these distances does require a level of technology that man has not yet achieved. But it has nothing to do with flying in a linear mode. near the speed of light. We know that the shortest distance between 2 points is a straight line, so in our universe we've always assumed that the fastest way from point A to B was to travel in a straight line at the speed of light. Well, the fact is that when you're dealing with space-time and you enjoy the capability of generating an intense gravitational field, the fastest way from point A to B is to distort or warp or bend the space-time between point A and B, bringing point A and B closer together. The more intense the gravitational field, the greater the distortion of space-time and the shorter the distance between points A and B. Most of us think of space-time as the void or as nothing. And remember, it wasn't that long ago that man considered the air in our atmosphere to be nothing. Yet with time, we've become aware of the elements and properties of the air in our atmosphere. Well, indeed, space-time is an entity, and one of its properties is that it can be distorted or bent by a gravitational field. We know that gravity bends or distorts space-time and light by virtue of the fact that we're able to see stars which we know should be blocked from our view by the sun. Referring to the graphic here, the solid line denotes the position of a star that's located behind the sun, and the dotted line shows its position as viewed from Earth. This is made possible because the sun's gravitational field distorts the space-time and light around the sun, allowing us to view stars which should be hidden from view. We know that gravity distorts time by virtue of the fact that if we take two identical atomic clocks and keep one at sea level and take the other one up to a high altitude, when we bring them both back together, they reflect different times. The difference in this passage of time is caused by the fact that a gravitational field weakens the further you get from the source. So the atomic clock which was taken to the high altitude was exposed to a less powerful gravitational field than the clock which we kept at sea level. The effect of a gravitational field on space-time is something that we've been able to observe, but not to experiment with. This is due to our inability to generate a gravitational field. And up until this point in time, great mass such as a star, planet, or moon was the only source of a discernible gravitational field that we're aware of. So just as the gravitational field around great mass such as a planet distorts space and time, any gravitational field, whether naturally occurring or generated, distorts space and time in a similar manner. Now, the great benefit of generating an intense gravitational field is not only can you turn it on, but you can turn it off. If we refer back to our original illustration of space-time distortion, we can see that when we generate an intense gravitational field, we can distort the space-time and in turn the distance between the point where we are and the point where we want to be. We can then position ourselves at the point where we want to be and then stop generating the gravitational field, allowing space-time to return to its natural form. In this manner, we can travel great distances with little linear movement. And this is how space-time distortion translates into reduced distance. Now back to our original question, how is it possible to cross the vast expanses of space required for interstellar travel without exceeding the speed of light? This is accomplished by generating an intense gravitational field, distorting space-time and allowing you to cross many light years of space in little or no time and without traveling in a linear mode near the speed of light. The next question is, how do you generate a gravitational field? Up until this point in time, I've used the term generate to describe the capability of producing a gravitational field, but since I'm not aware of any way of creating a gravitational field from nothing, a more accurate term might be to access and amplify a gravitational field. And this is what I mean when I use the term generate. To understand how gravity is generated or accessed and amplified, you must first know what gravity is. There are two main theories. The wave theory, which states that gravity is a wave, and the currently accepted theory of gravitons, which are alleged subatomic